Today I'm going to look at a Pioneer sub that was brought in for service with an intermittent problem. This one features a BASH or BASH amplifier, one that I don't think I've worked on before. This is kind of a hybrid between a Class D and a Class AB amplifier. We'll explain a bit about how this thing works a little bit later on, but first of all, let's get a look at this thing and see if we can figure out what's causing all this noise. And it's actually simple once I get it apart. So for those that are not familiar, there are a couple different classes of amplifier. You've got your Class AB, which is a full analog push-pull amplifier. Then there's the Class D, which some people call a digital amplifier, but it's actually not. It's actually a pulse width modulation amplifier, switching quick between the two rail voltages and then using a low-pass filter to filter out the high-frequency switching. There's a Class H amplifier, which is basically a Class AB with two power rails, a high voltage and a low voltage, and it can switch back and forth between the low and the high voltage. And then there's BASH. BASH uses a Class D amplifier as a power supply feeding a Class AB. And the rail-to-rail voltage is actually variable from low voltage for low sound levels to high voltage for high sound levels. So let's just see whether it works. It is certainly rattling everything in the shop here. I just have music playing through it, obviously. I did hear it faulting, and it sounds like a loud crackling sound, like it's losing power. Looks like this thing's been bashed around a few times from the corners of it here. It looks like it's been beat up pretty good. Well, I think we'll pull this thing apart and just see if there's anything obvious. Subwoofers, of course, just from the very nature of how they operate, are generally subject to pretty good internal shocks, internal vibrations. This will be a plate amp, so the amplifier is going to be right mounted to this metal heat sink here. Oh, see? There's what he's complaining about when I was moving it there. I think we got a problem right here. The only reason I found this so quick is as I was removing the back, this scraped up against the back of it. You see, that wire was rusting up against here, and as I removed the back, it rubbed against it. That's the only reason I found this thing as quick, is because I wonder if there's a connection problem in here. Yeah, I think we got a problem right in here. I'm just going to power this thing down, and let's take a look at those solder connections on there. It could be the plug too. I'm curious as to where this thing was made, because you see the transformer was made in Canada. I wonder if this amplifier was made in Canada. The transformer certainly was. Circuit boards look to be really high quality too. I'm curious as to whether it's this plug that's at fault. I got it unplugged now, but because it just moving this back and forth caused it to cut in and out. The plug snapped in, right? It's not like it's out or anything. But that seems to be where the problem is. It could be the connector here is at fault. So this is the Class D. The one at the bottom, that board there, that's actually the Class D amplifier. That's just the power supply. So the audio signals are routed through this, and it's used to adjust the voltage up and down that feeds the other amplifier on the right. The board on the right is going to be a conventional Class AB or Class B amplifier. It's got 4 outputs on it, so it's going to be a high power one. The black and red wires going onto the board, the 2 leading off the board going to the speaker. The other 2 black and red wires are the power supply output from that Class D power supply. Those connections on this plug down here and see how they look. Now that one there might be bad. Grab something to poke at that with. I mean, subwoofers are the one thing that do vibrate a lot, so that one down there, I don't know, that one might be, it's hard to tell from here. It looks like there might be a bit of a crack. Something definitely on this plug, because this is the one that I was wiggling around. I'm just going to reflow that connector. We'll resolder this connector here and try it again. See whether it still acts up. Looks like this was made 2000, 6th month, 5th day 2000 from the power transformer here, as you can see. And what's interesting about this transformer is this looks just like it's just a straight isolation transformer. You notice it just says black, 120 volts, 60 hertz, secondary white. It looks like the secondary is 120 volt output on this. So this is a high voltage amplifier. We'll check it. But just from the numbering here, we don't have a secondary voltage. I would imagine at the secondary voltage, this is just a straight isolation transformer to provide isolation from the line. The main input just goes through a fuse and a choke. Here's the transformer input. The transformer output goes straight down to this board. If we look at the capacitor, there's a bridge rectifier on here, right here, and the capacitor is rated at 200 volts. As you can see, 470 microfarad, 200 volts. So this is going to be just a straight isolation transformer, 1-to-1 isolation transformer. So this will be a high voltage amplifier. So the Bash amplifier is actually an implementation of a Class H amplifier, which is similar to a Class G. A lot of people get Class H and Class G mixed up. The big difference between Class H and Class G is a multi-step rail voltage, which is more like the NADs, which had a low voltage and a high voltage rail, and the amplifier could switch back and forth. whereas a Class H uses a variable rail voltage. The rail voltage is modulated depending on the sound required, the sound level required. And that is the Class D amplifier. The bottom circuit board there is what modulates that rail voltage. And I should point out that Bash is a Canadian design, a Canadian solid-state hybrid design, Class D and Class AB combined. It's a way of making them more efficient because you don't need such a big transformer. How NAD does it, though, is they have two separate windings on the transformer. They have a low voltage and a high voltage winding. But first things first, let's reflow these connections on this plug. And see whether that makes any difference. See if it still cuts out when I wiggle the cable around. If it doesn't, then it's a good chance that's where the problem was. Well, we know that's where the problem was because just by fluke, I happened to bump it when I was taking it apart. Had I taken this thing apart with the power off, I wouldn't have found it anywhere near as quick as that, but it was just by fluke that when I was removing the actual amplifier, it was on, and I heard it. Of course, it's that wonderful lead-free crap that my leaded solder doesn't like to stick to very well. Gonna have to flush the lead-free crap out of there with good quality solder. Okay, we'll plug this back in. And plug this one in over here. Okay, let's plug it in, see what happens. Apparently nothing happens. Might help if I turn on the switch. I believe I have it. Interesting. Let's take a look at the voltage on that transformer and see if I'm right that it is a high voltage transformer. Or not a high voltage, but isolation. Just a straight isolation transformer. So AC volts. So our input on this thing is 120 volts. And the output, oh, it's actually higher. It's 138 volts. Interesting. It's a step-up transformer. Here's our input, 120.8, yet I have almost 140 volts here. Interesting, a step-up transformer. It says Frost 130. Well, it's going higher than 130. So the DC voltage on this thing, let's just measure the voltage across the capacitor. Just see how much voltage this thing's running on. On DC, I'll just put my meter across the filter capacitor, and we see that it is running at 180 volts. 183 volts. Wow. A high voltage amplifier. Interesting. Okay, well, that's how they get the power out of these things, right? They step up the voltage. Anyway, I'm going to close this one up now and send this one back to its owner and have him try it and see whether the fault that he was complaining about is cleared up, because I certainly think that's where the problem was, because all I had to do was just touch it and it was snapping, crackling, and popping. So, there we go. I'm just looking at some of the warnings on the Californian Proposition 65 warning. This product contains lead in solder and certain electrical parts. It contain chemicals which are known to the state of California to cause cancer, birth defects, and other reproductive harm. There's a sticker on the back here. It's upside down. I'm reading it upside down to you. But yeah, sticker on the back there. That's going to really warn anybody, right? They can't see that until they actually open it up. Anyway, yeah, I'm going to put this thing together now, and we'll call it a day. That was a nice, simple one. Sometimes we get lucky, It's just sometimes when, you're taking something apart and something moves, and it's a connection problem. Anyway, neat little amplifier. Transformers made in Canada. Chances are these boards were also made in Canada. They look like Canadian type boards the way that they're laid out. They look like well-made, fiberglass boards. Anyway, I'm going to put this one together, and send it home, because I don't see anything else I can do with this one. I think this is our little clue here where this thing's made. I'll just read you something here from PS Audio. I'm sure you've heard of PS Audio. They're a big audio manufacturer in the States. So we're going to talk about Bash amplifiers. A Bash amplifier is a Canadian design. This amplifier topology uses a Class D amplifier to feed a Class AB, replacing the traditional power supply, thus removing the need for output filters, yet keeping the efficiency high. A Class AB amp is maybe 50% efficient because the power supply feeding this type of amplifier has fixed levels, typically very high levels like 150 volts, and the amp moves between these levels as it produces sound. This is not a very efficient way to do business. However, the power supply of a Class AB amplifier had small fixed levels, perhaps 10 volts, and then it would be very efficient. The only way to accomplish this would be to have a power supply levels to the AB amp moving up and down with the music. There's that second board, right? This requires a power amp, or this requires a power amp, thus adding a Class D to take place of the fixed power supply to solve this problem. So that second circuit board that we're looking at, that is a switching power supply. That is, I thought this would be maybe a Class H, because a Class H uses a dual power supply like NAD's design. And as I said before, typically they have two secondary on the transformer, one high voltage, one low voltage. But in this case, it's not. It's actually using that other one is a Class D amplifier that is using that just to raise and lower the voltage. So the advantage of a Bash amplifier over a Class D amplifier, and I'm going to read this right from PS Audio. Okay, in the end, a Bash does not have a problem with the output filter between the speakers and the power amplifier. That's the difference between a classic Class D approach, and they both work just fine for a subwoofer. So a Bash amplifier, which is what this is, Canadian design, so guarantee those boards will be made in Canada. The one circuit board is the Class D power supply, which is supplying power to the Class AB output, allowing the rail-to-rail voltage to rise up and down. So it could be 40 volts or so when the output power is low, but when it needs a higher output power, the voltage can be instantly turned up to whatever level you need. That's the design of this one. Now you know. So we learn something new every day. Bash. Seen those before, but I've never really done any research on them until today. And interesting design. Anyway, this one here is back running. We'll plug it in again now that I've put it together just to make sure that it still works. Line in. Making my bench shake. Anyway, there we go. That one's back together. Nice, easy one to fix. Anytime you have subwoofers, you have to always consider that it may be vibration that has shaken something loose inside. Thanks for watching.